Good morning, everybody. Today we'll talk about the significance of implicit differentiation and how it's different from normal differentiation. Implicit differentiation is essentially a special case of the chain rule for derivatives. The majority of differentiation problems involve functions where y is written explicitly as functions of x. For example, this equation is written as y equals a function that only has x as a variable in it. Its derivative would simply follow rules as normal. But in cases like this equation, the problem is not written in that format. To solve this, we can treat the y squared as a f of x squared, as is done in regular differentiation problems. The f of x is implied, hence the name implicit differentiation. Differentiating f of x squared requires the use of the chain rule since it's a function nested in another function. The equation x squared plus y squared equal 25 describes a circle centered on 0, 0 with a radius of 5 units. Say you were asked to find the slope of the line tangential to the circle based on the equation at 3, -4. We would differentiate with respect to x, which is what the d over dx means, on both sides of the equation. For the x squared and the constant, you would derive normally. For y squared, the chain rule applies since we are treating it as f of x squared. Remember that the chain rule multiplies the derivative of the outer function with the derivative of the inner function. In this case, the outer function is d over dy of y squared, because the exponent, 2, is our outer function operating on y. And the inner function is dy over dx, because y is some expression with x's in it. D over dy of y squared follows normal rules and becomes 2y. dy over dx can be called y prime, which is the derivative of y and what we're looking for. We can then isolate y prime by subtracting the 2x and then divide by 2y. This leaves the equation of -x over y. All that's left is to solve at the coordinates provided. The coordinates, 3, -4, can be applied into our derivative equation and would yield the slope. Hopefully that helps with explaining how to use implicit differentiation and how it's a specific case of the chain rule. Have a great rest of your day and good luck with your course!